Good morning, everyone. I hope I am audible. Okay, great. Thank you for confirming. Uh, Today we'll continue with where we left last to give you a small background of what we have done. In the last class, we were looking at an example of linear regression. We were using the house pricing data set, and we had already prepared our data. That means that we had dealt with all the missing values. We had taken the categorical data and done something called as one hot encoding on that data. So one hot encoding is basically where we uh, where we take that data and we convert that into multiple columns. Yes. One hot encoding is we take that data and we convert that into multiple columns. So that for two purposes. One, that our text is converted into numbers which our model can read. That is part one. Part two is we don't want any implied hierarchy by the numbering that we are giving. So to ensure that, we do one hot encoding. So we did that with the categorical data. Additionally, with the numerical data, we did something called as scaling. And the purpose of scaling was so that our features will not be biased and our model will be able to equivalently pick up from any of the data, from any of the features and learn accordingly how the output variable is linked. So let me quickly run through the steps of what we did yesterday and how we prepared the data. And from there, we can take it to the next phase, which is machine learning. That is, on these prepared data, we can learn on these prepared data, we'll be able to train a model that will be used to predict the price of the house. Okay. So since this is already loaded, I think I can directly jump to the next part. Means I don't need to run this notebook. You see, when I ran this cell, it incremented to 102. Basically means that since yesterday I have not closed this notebook, so it is still active. We read the data description. We saw the description file. We loaded the data into df train and df test. Df train is all of these columns. So here we have exceptionally huge number of columns, that is 81 columns, of which all of these columns are input data features from which we want to predict the output price, that is sale price. We did exploration where we divided the data features into numerical features and categorical features. And as you know from ahead, the advantage of that is we can have two different pipelines, a categorical pipeline and a numerical pipeline, so that we can prepare our data separately for categorical features and numerical features. So we take that, divide that into two features. We saw ask questions like how many data points are there any missing values? So this is where we spend most of our time figuring out how we can fill those missing values so that our model does not get stuck. And in most cases, especially for this data set, we found that the missing values were a result of improperly capturing the data. So the possible options for the data was NA, whereas whoever was populating the data did not fill with NA, but they left it missing, because of which we have a missing value here. So when we replace this missing values NANs with the value NA, which is not available, then we have taken care of missing values. Okay. So one good tip when we are exploring our data as a beginner data scientist, we would want to think about the thought process on why the data looks this way. What was the process in which the data was collected? So I would imagine that this data was probably collected through real estate agencies throughout the Boston area. And that is why we've got multiple data points, so thousands and thousands of data points, where they help us to evaluate so many different features. So I am sure there must have been a survey form, and whoever was the agent would have populated this survey form for each of the houses they visited. And by leaving it missing, there would have been a process in which that survey form would have been digitized. And after it being digitized, it has been converted into a CSV, which now we have an access to. So within this process, there are several places where the data may have gone missing. So just thinking of the fact helps us to analyze or become a better data scientist, because we become then more closely associated with that data. Okay. Nonetheless, once we have it in our CSV form, at this stage, we have to deal with our missing values, to fill our missing values. Okay. So we come down, we saw all of this. We saw how hints from other parts of the data can help us to fill out the missing values. We spent some time in particularly something called as lot frontage, where we used an advanced technique to fill the missing values, where we said that we'll not basically fill with mean or median, but instead we will train a linear regression model in which lot area is the input, lot frontage is the output, and this linear regression model can help us find out missing values from the training example that we have. So for training example, everything that we had data for, we used as training example, and everything where data was missing, we used the linear regression model to find out the missing values there. So this was a pretty interesting exercise. Uh, okay, we also dealt with outliers. Going ahead, we replaced what we say, we trained a linear regression model, and then we populated the missing data with that. Then we had different missing values like garage and other things, which also we explored the data and we found how to take care of the missing values, and we dealt with that. Once train was finished, we also saw that the test data set has some examples missing, which the train did not have. So we had to deal with that separately. So all the training examples with tests also we filled, with which we came to our next phase, which was data modeling. And here we used pipelines to help us to prepare the data for the machine learning model. So once we had dealt with missing values, we created two different pipelines, numerical and categorical. In this pipeline, we are doing very simple things. We are just doing selection of numerical features and scaling of numerical features. Similarly, for categorical features, we did selection of categorical features and one-hot encoding of categorical features, which are very standard pre-processing steps. We combined both the pipelines into something called as full pipeline. And once prepared the data, we had this as our answer. Okay. So now our full pipeline consists of 1460 different data samples with 334 different columns. Okay. So we have a huge number of columns, especially because we did one hot encoding over our 46 categorical features, which increased our data, which is fine. And this is where we had left last time with our prepared data. The next step is how we can take this prepared data and and uh, train our linear regression models. Okay, so here we call the scikit-learn module, scikit-learn package, and within the scikit-learn package we call something called as a linear model, which is a module from which we import three methods: linear regression, ridge, and lasso. So we have seen linear regression, we have not seen ridge and lasso. Ridge and lasso are exactly like linear regression, with the additional advantage that ridge and lasso have regularization terms. Okay, so if you remember from our previous classes, regularization is something that will prevent our machine learning model from overfitting. Okay, when our model overfits, then our model is highly biased towards the training examples, but does not do well or does not generalize well to unseen data. But with regularization, we can say that we have some level of control where we can say our model should not learn too much from a training example and it should only generalize. So ridge and lasso, they are extensions of linear regression, which helps in generalizing the model. So we take all these three, or we load all these three machine learning models. We call cross-val score that will help for our cross-validation. We call k-fold that will divide our data into splits. And we call something called as mean squared error, which is a standard metric for linear regression. Okay, so we load all these packages. We call the k-fold. And for the first part, we just take a standard linear regression model and see how well it does. Okay. So we take linear regression, create an instance of linear regression class in this variable LR underscore reg. For this LR underscore reg, we fit our data with the prepared X data and the Y train. And once we have prepared it, once we have trained the model, we want to see what is our training accuracy. So we predict the output of our model for the same prepared data. We get Y prediction, and the difference between Y prediction and Y train will tell us how good our learning was. So we take mean squared error between Y train and Y prediction. We keep square as false. Square as false will give us root mean square error. So the same function, mean square error, can help us to give root mean square error also, which is the standard metric. After executing this, we see that we get a root mean squared error of 19,766. Let us see what our individual cross-val score is. So we see our cross-validation scores are mean of the cross-validation and standard deviation. Okay. So at this point, it is very difficult to say how good or bad this model is. So we'll have to, of course, compare it with different models and see how the error changes. And the error with the lowest RMSE, that is the model with the lowest root mean square error, will be our best model. Okay. So this helps the first training with just the training accuracy helps us give a baseline score. Okay. Still, what has this baseline model done? It has taken all of our X, prepared, and you know the equation, the hypothesis of the linear regression. The hypothesis of linear regression is my Y hat, that is my output, is equal to theta 0 plus theta 1 times x1 plus theta 2 times x2 plus so on till theta d xd, where d stands for the dimensions of our data. In this case, we have 334 dimensions, and thus you can imagine we have a huge number of parameters to learn, and a linear regression model has learned those parameters, fit that data, and now we see what is the error. Okay. Going ahead, we can do further fine tuning of these models. So if you remember, just like in our classification algorithm examples, we did something called as fine tuning. And the purpose of fine tuning is we have multiple hyper parameters within each learning algorithm. And these hyperparameters have to be played around with, have to be tuned so that we can come up with the best choice for training our model. Okay. So in this case, we will go through grid search CV, that is grid search cross validation, that can help us to evaluate how good or how bad our model is, or can help us to evaluate on multiple parameters. So here I call grid search CV. When I look at linear regression specifically does not have any parameters because if you remember the equation, that's the simple equation that we have. There is no complication here. So we can run this step for just our 5 parameters, and we can note down our algorithm, our training RMSE, that is our training root mean square error, our validation root mean square error, and our validation standard deviation. Okay. Here we are just calling grid search CV with an instance of linear regression. Parameter grid, in this case it is empty, but as we see, go ahead with ridge and lasso, we'll have some more parameters to check with. We define our cross validation as k-fold. K-fold we have defined as 5 splits here. So we have a 5 split validation, and our scoring is negative of root mean squared error. And that's it. That's our exactly same code that we did for classification examples. Once we have our trained model, once we have our grid that we want to search in, we do a fit, which will search through all of the grids. We print the best parameters. We take the best estimator, find the cross validation score, note the standard deviation of the score, fit the entire data again with training model, check the training prediction, get the RMSE of this, get the root mean square error. So someone has asked the question, what is verbose? So verbose is, you see, when I'm running the model, I see this output where I am getting some kind of estimation on how long my model will take to run. So even when you're downloading, we use that ETA, right? how much percentage it is complete and how long it will take. So Verbose basically gives us this output. So for only 5 sets, it finishes pretty quickly. That is just 1.6 seconds. So this is not that important. But when you have thousands of different models to fit, Verbose gives us an idea of how long it will take. So if it is going to take 5 minutes, you can go take a tea break and then come back. That is the advantage. Okay. And we have different levels of verbose. Verbose 1, 0, 1, 2. The higher level of verbose means more data that you want to see. Lower verbose means just less data that you want to see. Okay. Which holds true not only for grid search CV. Many models have the same parameter verbose that can help us to identify how long it will take to run a model. Additionally, here once we have our validation fit and our train fit, then we can load them into a data frame so that we have this neat data frame in which we can easily compare our models. So we have done this for linear regression. Let's go ahead and do this for ridge. So let me do a help on linear regression first and see are there any parameters that we can play. So here, okay, here we have fit intercept, normalize, and copy. Maybe we can try these options. Okay, even for linear regression, let us try to use fit intercept. So I'll copy this. Let's say for this model, fit intercept. Try the options true and false. Then for the next value normalize, let us try normalize or not. Normalize will not be needed here because we have already scaled our model. But had we not scaled our model, we could also try this. So nonetheless, let us try with these options and see what we end up with. Okay. So when I execute this, I have 20 fits, and because of verbose, I get this output. It took 5.6 seconds, and still I get fit intercept true, normalized true as our answer. It's the same answer as before because those were the default options. Let us try with the ridge. So with the ridge, when I do this help of ridge, I can see some information on what formula it is using. There is a parameter. Okay, so parameter alpha, it decides the regularization strength. So let us try different values of alpha. Default value is 1. So I can take here for ridge, let me choose an alpha. Let us choose values as 0.001, 0.003, 0.01, 0.03, 0.1, 0.3, 1, 3, 10, and 30. Okay, so we can try all these options. So if you see, generally I choose my options in multiples of 3. That gives me a huge range. So even within 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, even with 10 parameters, we are testing for the entire range from 0.001 till 30. That is our alpha. Then we have fit intercept normalize. Default is true and false. Max iteration tolerance solver. Okay, maybe we can play a little bit with solver. Let us try these options, or let's just try for alpha. Okay, so once we execute this, we see we have 50 fits, and it chose an alpha of 10. So alpha of 10 gave the best result, in which we can see that our validation RMSE has improved to 31,352 compared from 34,000. Let us try one more model with lasso. So I'll copy all of this, paste it here, create a new cell, and say lasso. We will change the code here. I think everything else should remain same, and we'll change the name here to lasso. In fact, in the earlier one, we had not changed the name to Ridge. So here, even though the score belongs to Ridge, we see linear regression here. So let me update that to Ridge. Okay. So even with lasso, let's try the same parameter as alpha. And once we execute this, I might want to increase the iterations. Okay. So probably lasso takes some long time to run. Hence, we have this code. It says our number of iterations are less. You should go for more number of iterations, which is, I think, fine. Objective did not converge. Let's try with more iterations in that case. Okay, so I'll want to stop this code. You can do that by pressing the stop, and we'll do a help on lasso. And we have an option called as max setter, which is set to 1000 now. Let's change that to 2000 and see how this works. So we'll change max setter to 2000, and let us try a fewer number of examples here. This into list. So even with this, it is telling me that you might want to increase number of iterations. It is not converging. Let's increase number of iterations to maybe 5000 and thereby reduce this further. Okay, I guess this is why I had not tried lasso earlier. So maybe for this data set, lasso is not working well. Probably because there are many features with lasso. Nonetheless, we see from our two models that our ridge works best, and since ridge works best, let us select that as our final model. So final model will be ridge. So we will take ridge with alpha as 10. That is what we had found, alpha as 10. So let me build a model here and put alpha equal to 10, which is our best model. And we will fit this data with our X prepared Y X train and Y train. And once we have that, we can predict our model on data so that we can see how good our model did. And we can check its RMS yields. So let me take Y prediction here as well. Okay. So let us see what our Y pred is. And let's compare it with our Y train. So we could do a simple for loop. So for I in range, length of Y train, and we can print our answer. We can print our number. We can print what was the answer, and we can print what was our prediction. So just len. So we can see that this is the result of our model. For our first example, the final answer was 208,500, whereas our model gave us 206,592, which is, I would say, pretty close. And here, in each case, we can see our model is not as far from our prediction. Maybe we would want to find out what is the percentage difference. So let's try that. So we say y train I, that is our answer, minus our prediction, and we can divide that by y train and multiply by 100 to know what our percentage error was or percentage difference was. Maybe we can round all of the data to a closer point. Let's execute this. We can see that we are 1% less, 6%, 1% less, 6% more, 5%. Here is probably the largest difference, 30%, and so on. You can see most of our data is very close to, or most of our predictions are very close to what the model was wanting for. We may have huge differences in between, depending upon probably if the data itself was an outlier. But you can see a model like this can do very well for unknown scenarios or for unknown cases. Okay. So with this, I can summarize and finish something called as linear regression. Let me shift to my iPad so I can summarize our course so far. In fact, today will be our last class, where uh, we have gone through a long journey uh, of exploring so many different ideas and concepts, which I would want to, before ending, I would want to summarize. So let me share my iPad screen with you. 1 second. Okay. Okay. So maybe as I'm summarizing, it would be interesting if you have any questions, some general questions on the topic or questions that you may have faced throughout, which we never got a chance to ask. You can post that up in the chat, and I will try my best to answer to your questions. One question is, when will we get access to a recording of sessions? I think Nirja ma'am can help you in that. But apart from that, if there are any technical questions, you can post it up in the chat and I will try to answer. Let me quickly summarize a few concepts, or revise few concepts. What is data analytics? Data analytics is the process of inspecting, cleaning, transforming, and modeling data to discover useful information to support decision making. And this makes a lot of sense. Now, so this was probably what we covered in the first class, and after all these classes, we now realize what each of those steps do, right? Inspecting the data is something called as data exploration. Cleansing the data is we call data pre-processing or data preparation, along with transforming. So both of these we handle in data pre-processing. Modeling the data is where we have machine learning models in place, where we try to represent our data into formats that our machine learning models can understand or represent or replace even. And then we use that to discover useful information to support decision making. Okay. Going ahead, we also see what is the entire space of AI, ML, and data science. That is artificial intelligence, machine learning, and data science. So if you remember this part, artificial intelligence is the big boss, okay? Where we have fields like optical character recognition, autonomous vehicles, robotics, decision making, natural language processing, image processing, planning, and so on. And within the space of artificial intelligence, we saw a new budding space with not very clear boundaries called as machine learning, in which we have several things where we now see that each of these areas of artificial intelligence, our machine learning is trying to push further. That is, we are becoming better and better at machine learning, so that all these tasks of AI, which were initially handled by your conventional programming, are now moving to data-driven solutions. So machine learning models like decision trees, naive Bayes, reinforcement learning, logistic regression, and so on are examples of these ideas. Okay. We also saw that data science is some part outside AI, some part inside AI, and some part inside machine learning as well. So our space of data science is overlapping with the space of AI and ML, which helps us to capitalize, or which helps us to leverage machine learning ideas into data science. Okay, so data science starts with visualization, A/B testing, sampling, ETL, and so on. And within this space, we use machine learning models to predict for unseen or unknown data that can help us to make business cases well. Okay. We also saw why there is a growing need of analytics, because we have large amounts of data available. We have large storage databases which were earlier not available, which are available at lower cost now. We saw now we have many tools and technologies to analyze data. Without our analysis, the raw data is primarily useless for most of us, unless we can extract useful information from the data. It is useless. And another need for analytics is the business insights that we can understand from our data. We can understand how to recognize sales, how to recognize market opportunities, so that you can help your business to make decisions in that order. And finally, we see the growing need of analysis is for many organizations. This is the top priority. So I work in the aerospace industry, and even in my industry, when we look at, I work with a field called as diagnostics and prognostics for real-time systems. And in this field also, I see a huge push towards using data science. So our company is highly engaged in employing data science or data-driven solutions for our problems, so that we can leverage all the years of data we have collected to get some business insights. And this is not the case with just my company. In fact, a lot of different organizations and many of my colleagues working in their fields, the respective fields, we can see data science is very fast. It is entering into these fields. That means that it gives us a huge opportunity as engineers, or as fellow data science practitioners, to enter into this field and leverage this time, so that we can be of advantage to our companies. We had also seen that our data science, our analytics, can be divided into three basic parts: descriptive, predictive, and prescriptive. Where descriptive is trying to understand what has happened in the past, predictive is trying to understand what will happen in the future, and prescriptive is basically saying, if we know what is going to happen in the future, what should be the steps that we should take now. Okay, so most industries have already captured very well on what is descriptive. That is, they are able to analyze the data to find out what has happened in the past. They are progressing into this field, that is what is going to happen in the future, where we are doing predictive analytics, and very few companies are in the prescriptive area. Our hope is in the years to come, we will see more focus on prescriptive, so that we can advantage not just on what will happen, but based on knowing what will happen, we can also leverage what we should be doing about it. Okay. Now, machine learning is basically the task of taking data, training a task, and then measuring how that task will do using our metrics. Okay, so we take data like financial records or information regarding the house, square feet area, rooms, garage, observing human drivers, and what other users did. So based on this data, we try to train a model that will do good on a task, so that we can see how well it is doing on a particular metric. And the metric is very important, because it helps us to know how it not just tells us how good or bad we are doing, but additionally it also helps us to improve this task further. We also saw that machine learning can be divided into multiple spaces. Under the supervised space, we have two major branches, classification and regression. Under the unsupervised space, we have clustering and anomaly detection. And under the reinforcement phase, we have basically reinforcement learning. In our exploration, we have focused on these two areas, classification and regression. Okay, let me maybe, before going ahead, let me also summarize what we have done within classification and what we have done within regression. So within our classification space, we have seen multiple algorithms like we started off with KNN, K nearest neighbors. We have done decision trees. We have looked at naive Bayes. We have looked at random forest and so on. Along with that, we looked at our basic strategies of validation. So our basic strategies of validation have been threefold validation. That is our dividing our data into train set, test set, and validation set. We have seen cross validation. That means it divides our data into multiple folds, and for each fold we will see how how good our validation score is, and use the entire average. So that gives us more stable results. And we saw something called as stratified cross validation. And stratified cross validation is basically same as cross validation, with the additional caveat that each of our fold will have an equal distribution of the target class. Further, we went to our regression space. And within regression, we saw linear regression. We have tried multiple data sets as examples. So the data sets that we have covered is Titanic. We have seen Iris dataset. That is our flowers dataset, specifically when we were learning matplotlib and visualization. We saw heart disease prediction. We have now seen housing price, which is our Boston dataset, and so on. Okay, so in our journey in the last multiple hours, we have seen how classification works. To summarize, classification is, or any machine learning algorithm for that matter, is basically an empty box to which we are feeding our input features. So our input features like x1, x2, x3, x4, and x4, and we want an output y. If this y has discrete classes, that is fixed number of classes, this becomes a classification problem. And if this y is continuous, then this becomes a regression problem. And we saw all of machine learning is basically trying to take these ideas and try to fit this model. Okay, we are trying to take, sorry, not validation. We are trying to take classification or regression and trying to fit this black space, and hoping that this black space here can, which we don't understand. Okay, this black space is something that we have no idea what is, and we take our machine learning algorithms and we try to fit into this space, which we say is trying to interpret the relation between this input to this output. That is what primarily machine learning is. Okay. You can also see the difference between shallow learning or deep learning, which is basically shallow learning is where we do the feature learning, That is the task of identifying features and the task of exploring what features are doing. If a human is doing that, we call it shallow learning. And if the same task is done by a machine, we call it deep learning. Okay. So by machine means this is specifically talking about the next phase, neural networks and deep learning and so on. Let me go ahead. So with all that in background, uh, let me give you the roadmap of what is a good strategy for getting into data science. Okay, and while I'm doing that, uh, you could start posting your questions, which I will try to answer after we finish this data science journey. Okay, so let me go ahead. The first phase of entering into data. So I believe most of you are students and maybe some professionals also here. But nonetheless, irrespective of whether you're a student or a professional, if you want to start your career within the data science, the first thing that you should do is you should learn the basics. And in the last multiple hours, this is what we have been doing. Okay, we have been learning languages. So you can look at languages like Python or R. You can look at tools like Tableau, Power BI, and so on. You can learn what is data handling. You can learn what is data visualization. That is, how do you tell a story based on our data, and what is machine learning. So if you remember, we also spent a huge amount of time in Python, where within our language Python, we did things like this. Okay, we learned what is the basics, what are operators, data types, control structures. We saw what are functions, and finally modules. And within our Python modules, we looked at NumPy, Pandas, Seaborn, Matplotlib, scikit-learn, and so on. Okay, so we spent a huge amount of time doing the basics in Python, and probably one of the reasons for that is Python is the primary language that we use for data science. Okay, so we spend time in. You should learn the basics by spending time in languages, in tools, in data handling, in machine learning. And once you have done your basics, or once you are comfortable with starting off, you can move to the next major phase of your data science journey, which is building a data science portfolio. Okay, building a data science portfolio. And what this basically means is the things that you have learned so far, you need to showcase your skills. Okay, you need to show to the world how good you are at data science. Okay, the question is, how do you do that? The first thing is, with our present scenario, we've got loads of data available for any field that you may be interested in, whether you're interested in banking or engineering or maybe medical related data, or in the present crisis that we are suffering through corona disease, and we have plenty of data regarding corona on the spread of information, the division, and the demographics of the data, and so on. So the next step is find a good data set that you are passionate about. And once you find a data set, you solve the problems for that data set. What do you mean by problems for the data set? What is interesting in it? What pattern is it showing? Can I use this pattern to predict something that will happen in the future? Can I tell how this virus will spread, or how good my sales for my bank will do, or for this engineering problem, if I have a failure, how fast the failure will predict? What is the type of failure, and so on. So you solve your problems based on the data set we have. And once you do that, you make your solutions public. Okay, you can make your solutions public on websites like GitHub, on Kaggle, on LinkedIn, and so on. And when you do that as a sum, what you're actually doing is you're building a data science portfolio. And this data science portfolio is very, very important, especially when you're trying to apply for new jobs, or when you're trying to showcase your skills to your bosses or for your projects. Then your data science portfolio will help you in this task. You can add this in your resume. So even if you do not have a formal education in computer science, or you don't have a formal education in data science, you don't have certifications, your data science portfolio can help improve your resume so that it looks better for your employer to hire you. No one wants to hire someone who does not know anything and then teach them, right? So if you already know something, you need to showcase your skills accordingly. The next part is to create a good resume. Okay, to create a good resume, you have to custom or showcase your data science skills. You have to see what experience you have, what education you have, and how you can link them with your data science skills. Maybe you had taken a course in calculus in your engineering, and you can highlight that to show that you are good at calculus, which makes you automatically good at data science, because a huge part of data science is calculus, linear algebra, and so on. Your resume should highlight your projects. So your projects can be something that you've done in your studies, or it can be something, it can be one of these projects done for a data science portfolio. Okay. So your resume is probably the next major step in your journey. Finally, you come across with your interview, and here you prepare for common questions. So I would suggest a book here. Let me put the name of the book down. You can see a book by Ramsey Pulgara, and what he has done is he has collected a collection of data science interview questions. Okay, so this is just a huge list of data science interview questions that can be used to prepare for this phase. It's the book is freely available. If you just search on Google, probably you'll find it, and you can prepare common questions. You can talk about your projects in your interview. You can showcase your hard skills and soft skills. Okay, so your soft skills are very important. People generally don't pay attention to soft skills, but how you speak, how you portray yourself, your confidence, your fluency in language is very important in grabbing that job. Okay, so that is what you do in your interview phase. And finally, data science is a huge journey. We have just explored the tip of the iceberg in our courses so far. Okay, it's a huge journey. In fact, even after years of data science, I am still learning every day so many new things. Okay, so it's a lifelong journey where you have to continuously upskill. Okay, every few months, data science will change. You will have new methods come in. You have new ways, new strategies, and you need to know how to update yourself or how to change yourself so that you can learn those new strategies to solve your problems. You can read multiple blogs. So these are two excellent blogs that I would suggest. Something called as Towards Data Science and Analytics Vidya. These are, especially for data science, these are excellent blogs that you can read. You can listen to podcasts. So again, these two are very famous data science related podcast, OC Devil ML0101. If you just Google these terms out, you will find the exact links and resources available. So I like OC Devil because this guy, he explains your data science concepts in very simple terms. And since it's a podcast, you can listen to it while driving, while sleeping, or just before sleeping, or instead of spending time listening to music, you can spend time listening to these podcasts, which can help you quickly upgrade your skills in data science. Data Skeptic is another great podcast. It is by a guy named Kyle, and he takes interviews of many famous data scientists, which can help you know how data science is used in different fields. So in the field of advertising or finance or engineering, you would want to know how they are used so that you can apply it on your projects. Another key thing to do for lifelong learning is to work on more projects. Okay, so we talked about building your data science portfolio. If you work on 5, 10, 20 projects, you will automatically gain the experience that is required for any standard job. Okay. Finally, you can also compete on competitions. So time and again, there are many companies that launch hackathons, or there are many companies that host their problems on Kaggle, and you can explore those problems and you can participate in those competitions. Okay, which brings me back to this circle. Okay, so in this circle, once your lifelong learning begins, you again go back learn the basics. Okay, because by the time here you may have either forgotten your basics or there are new things that come up. So this is a round circle. Okay, In fact, this journey keeps on going. And I would suggest that is how I have planned my data science journey. I think this is a good strategy to go on with. The best thing, the best way that you can learn data science is by getting a good job in the data science field, because there is nothing like learning on job. Okay, because that will reveal you real life problems, real life questions that you would want to look answers for. With this, I think I have finished whatever I wanted to talk about. But I don't see any questions within the chat group. If you have any more questions, I am still available for the next 5-10 minutes, and then we can discuss them. Else, we can stop here. Okay, if you have any questions, you can post it up. Okay. What is role of data science R language? Okay. Okay, so let me tell you. So when you begin with, I generally start teaching students with Python, primarily because Python is a language which is very easy to start learning with. The syntax is very intuitive. You would have seen the programs that we have done so far. It is very easy to read through and understand. Now R is specifically used in the academic world. Okay, so if you're taking a proper course, uh, an academic course, uh, people generally use R because you would want to modify these algorithms according to your tastes, and you would want to change these algorithms and so on. But professionally speaking, I think Python is more important. Why? Because all of the companies that I have worked for in the past, and all of the companies that my friends are working within the data science community, I know no company that is using R. Okay, they primarily use Python. And the reason for that is this, because Python has a very good interface with other languages. Okay, and since it use and since because of that background, Python is the choice, because then you don't have to invest into other infrastructure in getting things done. R is good. R is good for academics. But if you're looking for jobs in R, it will not harm you. Of course, it will not harm you. The more you know, the better. But if you are a fresher and you're just starting out, I would suggest you spend more time in Python. Get familiar with Python, because you can do all of your tasks in Python itself. Okay. About career in data science for freshers. Yes, so this entire journey is actually talking about freshers. So not just freshers in data science, but in general, even if you're just finishing your engineering, or if you're finishing your bachelor's somewhere, you can take up data science as a career option. Uh, okay, yeah, here you can take up data science as a career option, where this is a good strategy. Learn the basics, build portfolio, create your resume, apply for interviews, continue to learn, improve this further. And the more number of portfolios that you have here, the easier it will be for an HR to give you the call for going towards interviews and so on. Which portfolio is best to improve more skills in data science? So I would suggest highly go to this website Kaggle, and try exploring the different notebooks that people have submitted. Try participating in competitions. In fact, even on Kaggle, there is a learning platform. So if you want to learn on Python, you want to learn on data science skills, on scikit-learn, on how to use pandas and so on, Kaggle has a good place where it is a self-directed, uh, what do you say, a course which you can practice your data science skills on. Additionally, you have access to YouTube, Coursera, and so on. Even on eLearn Oak, we have multiple courses for data science. and you can take any of them and you can improve your skills based on that. Okay, do you have any more questions? Okay, thank you so much. Pirjaman, uh, if there aren't any more questions, can we stop here? Thank you so much. It was wonderful teaching you guys. I understand that uh, this interface is bad in the sense that, this interface is bad because you cannot ask your questions verbally. Probably because we are a huge bunch, right? So when we started off, there were 150 plus students. Even now there are 47 students. If you ask questions verbally, it will be very difficult. Hence, the only way of our communication is by via chatting. It can be difficult at times, but probably that is the only best option we have so far. Unless technology advances to a point where we have more, what do you say, a better mode of communication, then it will be better. You have been a good crowd. Thank you so much for this opportunity for teaching you guys. Uh, okay, maybe we can stop here. Uh, and let's hope we'll meet sometime in the future. Thank you. Bye bye. Okay, you want to share my mail ID? I can do that. I will do that here in the group. Okay. So in case you have questions or you want to discuss something in the future, you can mail me up, and that is fine. Okay. Thank you. Bye bye.